Somewhere out there, in the vast ocean of stars, planets just like our Earth are orbiting their suns. But how do we find these elusive worlds? Let's explore. First up, starshades and coronagraphs. These aren't props from a sci-fi movie. They are real tools used by astronomers to block out blinding starlight, revealing the planets hiding in the shadows. A starshade is like a giant umbrella in space, positioned between the telescope and the star, while a coronagraph is a sophisticated mask inside the telescope that dims the starlight. This technology allows us to see the planets as mere specks of light. Now, let's talk about the future. The Habitable Worlds Observatory, or HWO. This proposed space telescope could be a game-changer. Although still in the planning stages, the HWO could use a starshade, a coronagraph, or maybe both. The goal? To pinpoint planets that could harbor life. But as you can imagine, developing these technologies is no small feat. Labs around the world are rigorously testing them in different conditions to ensure they can operate flawlessly in space. And what are scientists looking for in these tests? 3 key parameters: raw contrast, post-calibration contrast, and off-axis throughput. These metrics help determine how effective the technology is at spotting those faint signals from distant planets. The quest to find Earth-like planets is not just about curiosity. It's about understanding our place in the universe, and maybe, just maybe, finding out we're not alone. So, stay tuned, keep looking up, and keep wondering, because every star in the sky is a sun, and around every sun there could be a new world waiting to be discovered. Now that we've uncovered some of the futuristic tools astronomers use to hunt for Earth 2.0, let's delve into other fascinating methods of exoplanet detection. First up, the transit method. Imagine watching a star twinkle in the night sky. When a planet crosses in front of that star, it causes a tiny dip in its brightness. This method has been incredibly successful, thanks to the Kepler Space Telescope, which has discovered thousands of exoplanets using this technique. Next, we have the radial velocity, or Doppler method. Think of it like a cosmic dance. A planet's gravitational pull causes its star to wobble slightly. This wobble induces a Doppler shift in the star's light, changing its spectrum. By measuring these shifts, scientists can infer the presence of an orbiting planet. Then there's direct imaging. This method is as challenging as it sounds. It involves capturing actual pictures of the planets themselves. Direct imaging works best for large planets orbiting far from their stars, where the star's glare is less overwhelming. Another fascinating method is gravitational microlensing. Picture this. Light from a distant star is bent and magnified by the gravity of a massive object, like a planet, passing between the star and us. This method relies on the gravitational lens effect and has been instrumental in discovering exoplanets that are otherwise hard to detect. Finally, we have astrometry, the oldest method of them all. It involves measuring a star's position in the sky and detecting tiny changes in its movement caused by the gravitational pull of an orbiting planet. This technique, though challenging, can provide valuable data about a planet's mass and orbit. Each of these methods brings us one step closer to finding new worlds. It's a cosmic puzzle, and with every piece we uncover, we get closer to answering one of humanity's biggest questions. Are we alone in the universe? Now that we've delved into the fascinating methods of detecting exoplanets, let's explore some of the remarkable recent discoveries that are reshaping our understanding of the cosmos. First up, the spunky exoplanet. Discovered by astrophysicist Samuel Grunblatt from Johns Hopkins University, this peculiar planet is smaller, hotter, and older than expected. What's truly astonishing is that it has survived the death throes of its host star, challenging our understanding of planetary lifespan. Next, we have a rare exoplanet with a puffy atmosphere. Identified through radial velocity measurements and data from NASA's Transiting Exoplanet Survey satellite, TESS. This exoplanet's unusually puffy atmosphere is defying current planetary evolution theories, prompting scientists to rethink their models. Then there's Gliese 12b, a potentially habitable Earth-like exoplanet situated just 40 light-years away. Discovered by astronomers, this intriguing world might offer conditions suitable for life, making it a prime candidate for future exploration. For those eager to dive deeper, Wikipedia maintains a comprehensive list of exoplanets discovered in 2024. This list details their mass, radius, period, semi-major axis, temperature, discovery method, and distance from Earth, providing a treasure trove of information for enthusiasts and researchers alike. Another groundbreaking discovery is the possible atmosphere surrounding the rocky exoplanet 55 Cancri e. Observations from NASA's James Webb Space Telescope suggest an atmosphere rich in carbon dioxide or carbon monoxide, hinting at complex processes at play on this distant world. Lastly, let's talk about the new ultra-short period exoplanet. Discovered using TESS, this exoplanet is nearly twice the size of Earth and orbits its host star in less than 1 day. Such rapid orbits are rare and provide unique opportunities to study planetary dynamics. These discoveries are not just milestones, they are windows into the endless possibilities that the universe holds. Each new exoplanet we find brings us closer to answering the age-old question: are we alone in the universe? As we continue our journey through the cosmos, one tool stands out as a beacon of hope and discovery: the James Webb Space Telescope, often simply referred to as Webb. This highly sophisticated space observatory is designed to conduct infrared astronomy, making it the most powerful space telescope ever built. It serves as the scientific successor to the Hubble Space Telescope, pushing the boundaries of our understanding of the universe. Launched on December 25, 2021, Webb operates from an orbit around the Sun-Earth L2 Lagrange point, about 1.5 million kilometers from Earth. This vantage point allows it to observe the universe with unparalleled clarity. The telescope boasts a large 6.5-meter primary mirror, enabling it to collect more light and see further into the cosmos than any previous telescope. One of Webb's most remarkable features is its ability to observe the universe primarily in the infrared spectrum. This capability allows it to look at objects that are too old, too distant, or too faint for Hubble to detect. From the first galaxies that formed in the early universe to the detailed atmospheres of exoplanets, Webb is equipped to unlock many of the universe's deepest secrets. The scientific goals of the James Webb Space Telescope are as ambitious as they are groundbreaking. It aims to study the formation of stars and planets, examine the atmospheres of exoplanets for signs of habitability, and explore the origins of the universe. Its instruments are designed with high resolution and sensitivity, making it an invaluable tool for a wide range of scientific investigations.